Network address translation, or NAT, is the process of mapping an IP address to another IP address, or an IP address port pair to another IP address port pair. Might be wondering, what is a software engineering doing explaining a concept that has been explained a million times on YouTube, right? And it's been there forever. Why are we doing this, right? I have a very good reason for that. NAT was originally designed to solve a virtually non-existing problem today. It was originally designed to solve the limited number of IPv4 addresses, which is I think 4 billion or whatever, right? With fridges and ovens connected to the internet, obviously that won't scale, right? So we needed to way to basically solve this limited problem. We invented NAT. Okay. However, that is not the only application of NAT I found. After a research, right? I was originally wanted to make a video about load balancing, to be honest, right? Layer 4 load balancing versus layer 7. And I found that NAT is showing up everywhere. So, you know what? I really need to understand what's going on with NAT, right? So, here it is, okay? So, load balancing or NAT is being used for many applications. And this is what I want to discuss in this video. If you're new here, welcome. My name is Hussein, and in this channel, we discuss all sorts of software engineering by example. So if you want to become a better software engineer, consider subscribing. And with that said, let's just jump into this video, guys. Here are the list of items, agenda, if you will, that we're going to talk about in this video. You should see some jump codes here that you can jump to if you don't want to listen to the whole thing. But essentially what I want to discuss first is TCP connection. The classical thing, I always do that in any networking video. I really need to explain just how TCP work, how connections work, what is a packet sent and all that stuff, just normally with a Node.js application or a Python application, right? And then we're going to explain how NAT works, why did we invent this thing, and then we're going to talk about some of the NAT applications, you guys. Let's start with an application here that say I have, and a lot of videos do this. I want to send a message from one computer to another computer, whatever that means, right? So want to put it in context what that means. Yeah. So let's say I have a computer here, okay, and this is 192.168.1.2, and this is my MAC address, AAA, and here's the target. Another machine could be your another laptop or phone, right? This is 192.168.1.4 and has this MAC address, right? And this is my router. This is the gateway of the router, and its MAC address is DDD. All right. So let's say I have a Node.js application here running on 192.168.1.4, okay, on port 8080, and I want to connect to it, consume it from my other machine. This is no problem at all. You know why, guys? Because these two guys are in what we call in the same subnet. They can communicate directly to each other without any problems because they are internal. They are in the same subnetwork, so they can find each other's MAC addresses using Arp, and then once they do that, they can send frames and eventually packets with the data. So let's discuss how this happens. So here's what we do. In 192.168, you want to send a GET request to the Node.js application on 1.1.4. Okay, what we do is we make a GET request. Let's not assume there is no TLS. If you want to learn about TLS, I'm gonna reference it here. But let's say no encryption, nothing. Okay, we take the GET request. I want to send it to the target IP address 192.168.1.4. This is the layer 3 thing going on, and I want to go to 8080 because it's not enough to just specify the IP. You really need to tell me where are you going, and then I am coming from 192.168.1.2. Perfect. These two can access each other. That's fine. And 8992. This is the random port that the client creates when it establishes a connection, right? So it knows, the server knows how or where to send the packet back. Okay, it cannot just send it to the IP. It needs to, because remember, guys, there will be a lot of TCP connections coming out of your machine, right? You really need to tag them with some sort of internal port so the target connection can come back to exactly your application. Whether this is a browser or another Node.js application, maybe a Python client, right? And here's what happened, guys. What we will do is we want to send this packet, and the first thing the client does is says, okay, 192.168.1.4, where is this guy located? Okay, it will do a /24, finds that, hey, 192.168.1, hey, this guy's the same neighborhood. We go back, all right? And then once we do that, essentially, we can do an Arp request. I didn't talk about Arp, but I don't think we need to make a video about it. It's very simple. The idea is we always communicate with MAC addresses. So we really need to know the MAC address of a machine that we communicate with. Okay, it's a low-level layer 2. I'm going to reference the OSI model video that we made. Really go ahead and watch it, guys, if you want to understand about these layers that I'm talking about. I talk about examples and do all this sort of things. So, all right, so 192.168 does our Arp request on 1.4. It finds that, hey, it's CCC, okay. Let's go ahead and forward, sir. And it will forward it normally. It will go through the router. But here's the router here will act as a dumb switch. Okay, dumb, maybe dumb is a very strong word. But it will essentially, the router doesn't have a job to route in this case. It is just a switch, right? Because it is literally in the same network. It's not going to be use its advanced capabilities to connect to the internet, right? It's just literally right there. So we'll just do that. Oh, you're connected to CCC. Beep. We'll just literally forward that thing, right? It might as well these two are connected to each other. Okay, forwarded. This app got the application, the packet, processes it. Oh, this guy want to go do a GET request. Okay, sir, I'm gonna give you back the JSON or HTML or whatever, right? And then I'm gonna send you. I'm gonna create a new packet. You are the target now. Whoever sent me this 192.168. Where is it going? Which port? 8992. That's the internal port that we created there at the other side. It's coming from me, and it is coming from 8080. It does an ARP request because you need to send it to 192. If it's in the cache, it's gonna find that it's AAA. If it's not, then it's gonna do the broadcast. Blah blah blah. Find the MAC address, and then say, shoot it up, right? Shoot it up to the router, and then sends it back, and then the client will start processing the request. Okay, simple stuff. So where does NAT comes into this picture? Let's say I have a server, right? But this is not in my network anymore. This is, I don't know, AWS or DigitalOcean, and this is the IP address, 44.12.19. It's as clearly a public IP address, right? And there's a Node.js application running, 8080, sweet. And I am here in my own little network, 192.168.1.2. First rule, 192.168.1, 10.0.0, 172.0.0, whatever. These are internal IP addresses. So the internet will never write, it will just drop them if it sees them. Okay, so this is the first problem. This guy cannot just send it, the request to the Node.js application. It needs to do something. It needs a public representation. It needs some sort of a proxy. Okay, not an actual proxy. I'm not going to confuse things. Okay, it just need a public representation as a public IP address. So what do? Here's our guy. Hey, Mr. Router, you have an internal IP address, which is 1.1. You're my gateway, all right? And then you also have a public IP address. You want to do me a solid and connect me to that guy over there? All right, seems like a grinder account. Okay, yeah, or girl. Okay, it doesn't have to be a guy. Okay, on the other end. Okay, 192.168.1.2 want to connect to 44.12.19. So what do? Similar thing. Let's just do it, right? I'm gonna make a GET request. 44.12.1.9. Right, that's the target. I'm going to there, and I want to go to that port, 8080. So far, no problems. Okay, and I'm coming from me. Similar thing, right? I'm coming from 192.168.1 and 8992. This port could be different, but you get the idea. Okay, what do we do now, guys? Can we just send it? No, because the first thing this machine does is says, All right, /24, 44.12.1, 192.168.1. Sir, you are not in my network, sir. I cannot send you. I cannot find you. I will not find you if I do an ARP request. Okay, so we cannot find your MAC address. So if in any situation a machine could not find the target machine in its subnet, it does a very smart thing that I recently know, believe it or not. It calls its default gateway. Some of you is like, really, you didn't know this? Oh, you're such a dumb. Yeah, I'm dumb. Okay, so it calls this gateway. If you go to your network connection, you'll always find in any network interface, you will always find your IP address, your subnet mask, which we talked about, right? To find your subnet, and then you find something called the default gateway, and this is where if you're not sure, you always send things there. Okay, that's your router. Okay, sometimes you can change it to be another machine, so you can do really fancy things with load balancing. But here's the tricky part. Okay, so what does 192.168.1.2? It sends the same thing to the gateway. But wait a second, the gateway is 192.168.1.1. You want me to replace that with the 192.168? I cannot do that. If I do, I'm gonna lose my destination server. How do I know where to forward it then? You cannot just replace this with 192.168.1.1, unfortunately, right? So what we do is a little hacky, but here's what we do. We send the same exact packet, but with the MAC address of the router. So we do an ARP request on 192.168.1.1, get the MAC address of the router, which is DDD, and forward the same packet. Don't touch it. Forward it to the router. The router is smart enough to say, okay, this is intended to me, but it's not really intended to me. Does that make sense, guys? So the packet came to the router, the frames, I would say, collectively came to the router and says, whoa, okay, this is addressed to me as a MAC address, but it's really not addressed to me as an IP address. So this guy must really want to connect to an outside world. Okay, the router does all of that, literally speaks to itself and does that. Okay, and then it says, okay, I want to connect to 444.12.1.9. Okay, sir, I'm sorry, I cannot let you go out there. You're almost naked. You cannot go out this. You have to wear some clothes. I'm gonna give you some nice attire so you can be properly presented in the outside wild internet. There are a lot of monsters there. Let me protect you. This is what the router says. And here's what the router does. Okay, the router receives this packet and says, okay, I received that. I know, I get that you want to talk to 44.12.1.9. Okay, and you're coming from 192.168.1.2. I know you from the other side of the hood. We know each other, but this hood is dangerous. I cannot just let you get out there. So we'll get to the point. I swear to God, guys. Okay, and here's what what the router does. It actually changes the source IP address to its own. Why? Because this is the public hood, right? And it says like, yeah, let's just change the 192 to 4. But wait a second, if you change it, how do you know how to send it back to the original? If you got results from the server, how do you know to send it back to this poor guy or girl? Right? How do you know that? This is where the NAT comes. Oh my God, how many minutes was that, guys? It's like, oh, you must be dying just to see this table now, huh? Okay, I'm sorry. You know me. If you know this channel, I always talk a lot, right? I don't care. If you want to make a 2-minute video on that, go watch it, all right? If you want to learn about software engineering, how things really work, you're gonna really want to watch 20 minutes video, okay? Okay, maybe there are some people better than me explaining things, but I like just to talk about things that are related to each other. Sue me, okay? Okay, so 192.168.1, we put the mapping here, and then we say, okay, I changed this to 88892. It could be a different port, doesn't have to be the same port. but we usually put the same port here. And then we say, okay, this packet, by the way, it went to that, and it put it as a stateful thing in its memory, okay? And here's the tricky part. I'm not sure if it's actually persistent on disk or not, on the router disk. I would say it's, and people, feel free to correct me if I said anything stupid or wrong. Okay, I'm not a network engineer. I read a lot, I did some research, and if there's something wrong, yeah, or just like, for example, stateful, or is it on disk or in memory? I don't know. I would assume it's in memory, because disk writes is really a lot of expenses, right? So you can forward that thing to the target port here, and then you just boot. So this guy receives, what does it receive? Receives this packet, right? So as far as this guy concerned, or this girl, they know that the packet came from the 44.1.5.17. I don't even know how to say numbers anymore. Okay, so it comes from here, and this is the internal IP address. So guess what? If it's gonna process this, build a JSON, where does it get send it? It's not gonna send it to 192. It doesn't know that there's a 192 behind that. Okay, so it's gonna send it to 44.145, and it's 8892. And it says, okay, this is coming from me. Okay, so it's gonna say this is coming from me, right? And this is going to this port. Okay, 8080. Just like that, we send it back. All right, and the router takes a look at the packet and says, huh, 44.157. Did we send anything to this guy before? Let's look at the table. Yes, we did, sir. Yes, we did. We did send something to this guy, and it's coming from this port. So, and the original guy or girl is this IP. So let's go ahead and change it. So we're changing the destination IP address to be the original guy, flood it through the other port, send it over, and this guy is happy. That's how NAT works. Makes sense, guys? Does that make sense? So this is in a nutshell how NAT works, but we took this and we pushed it to another dimension, okay? There are NAT applications out there. So the original thing, obviously, private to public IP translation, so we don't run out of IPv4. This is no longer a problem that we need NAT for. We have IPv6. It's what, 300 trillion? I don't even know the number, how many IPv6 there, but there's a lot of IP addresses. You can address the entire Earth and the alien society with IPv6 if you want. So if the alien came and invade us, they will have enough IP addresses if we can start using IPv6, right? Public IPv6s. Okay, we don't have to need to use this NAT, but we don't have to throw this technology out, because guess what? We use it on things like port forwarding. So here's an example. I don't know, guys, if you configured a Node.js application to listen on a port, right, on your machine. If you start listening on port 80, right, or like Tomcat application, you start listening on port 80, you're gonna get an error, right? Because there's, wait a second, anything that is less than 1024, I'm sorry, you cannot listen on these ports. These are root access ports, so I don't trust you. You cannot listen to that. So what we do is something with NAT, so that you can listen on port 8080 or 8081 or 8082 or 8083. You get the idea. But if you really want to expose the outside world to port 80 or 443, you do a port forwarding using IP tables, essentially. Is it called IP tables? IP tables. I think it's called IP tables, yes. So you use IP tables, and then what we do essentially is any request that is incoming to you in port 80, right? Even there is nothing listening on port 80, go ahead and change that port, right? So we change the port section here to 8080, and problem solved. So that's how we do it with the IP tables, okay? Load balancing. I'm gonna make another video about load balancing, but essentially what it does is it takes the packets that is coming into the server, and it creates a non-existing IP address, what we call the VIP, or the virtual IP address. Okay, so the virtual IP address gets an entry in the NAT table. However, what happens is the virtual IP address doesn't have a presence really. It's just a record in a table, right? If someone accesses this VIP record, we look at the table and this VIP has maybe 3 entries. Like it points to machine 1, machine 2, machine 3 with actual IP addresses. So if someone made a request to the VIP, we either take them to machine 1 or machine 2 or machine 3. All right, so that's in a nutshell the load balancing aspect of that. So you can create a table, you can map the virtual IP address to an actual IP address based on latency, based on response time, based on other aspects, right guys? All right guys, so this is our NAT video, guys. Hope you enjoy it. So let's go quickly through the summary of what have we discussed so far. So we talked about how TCP works, just a normal connection. We talked about how NAT works. We talked about the NAT different application. All right, guys, if you enjoyed this video, give it a like and subscribe and share it with your friends, and check out the other content on this channel. There's a lot of software engineering content, right? And we're gonna see you in the next one. You guys stay awesome.